Guys, in the last section we took a lot of hard looks at the segment addition postulate, finding unknown lengths, and talking about the distance when a point was between 2 points when the points were collinear. And then today, guys, we're going to kind of look at the same stuff, but what I want you to understand today is this. All right, we're still using segments. So again, a segment's a line that has a start and an ending point. So you're still going to be using line segments here in 8.3. All right. Title today is called Using the Midpoint and Distance Formulas. Midpoint and distance formulas. All right. A race is 26 miles long. What's the midpoint of the race? A race is 26 miles long. Where's the midpoint of the race? 13 miles. It's half, right? Very middle. If I had a number 4 and a number 10, where's the midpoint from 4 up to 10? Close. 4 up to 10, where's the midpoint?
7.
It's like the average, isn't it? What's 4 plus 10? 14. Divide that by 2. 7. So if you can think of midpoint as average between how many numbers? Think of midpoint as the average between how many numbers? 2. Yeah, a start point and end point, you'll find a midpoint value. And I think the very first topics we start discussing here in this section will make pretty good sense. I do think it's going to get difficult here towards the end, so you want to, like I said, make sure you pay good attention to this. Okay? In 8.3, we're trying to answer the following question. How can you find the midpoint and the length of a line segment in a coordinate plane? So in order for us to be able to do that, we need to A, find segment lengths using midpoints and what we call segment bisectors. We're going to use what's called the midpoint formula and use what's called the distance formula for this today. Okay? All right. Vocab-wise today, first one, midpoint. Okay, a midpoint is going to be the point on a segment that divides that segment into 2 equal segments. So for instance, guys, you have a line segment, like so. Let's call that line segment maybe AB. All right, that line segment might be AB. So a midpoint is going to be any point on that segment between A and B such that it divides A and B into 2 equal segments. In other words, if I put the point, and every time they do midpoint, they typically put the letter M in here. If M is the midpoint, I told you the distance from A to B was 6. What would that make the distance from M to B? 6. Okay? So what this is really implying is this. Segment AB is congruent to segment, I'm sorry, back that up. Segment AM. Segment AM is congruent to segment MB. What's the distance of AB, guys? What's the distance from A to B? How much? Not quite. Distance from A to B, think last section. 12, right? 6 plus 6. Okay? So this M is a midpoint if you can put it on that segment A and B and divide it into 2 equal segments right here. Okay? All right, then, guys, a segment bisector. A segment bisector is any point, ray, line segment, or plane that intersects a segment at the midpoint. Here I put a point in here, right? What's happening down here? Is that just a point, or are they using a ray to go ahead and divide that up? They're using a ray, aren't they? Okay. So a segment bisector is anything that creates a midpoint. So I'm going to write this down. Anything that creates a midpoint. And that can be various things. It can be a point, it can be a ray, it can be a line segment, it can be a line, it can be plane, any of those. It can be any of those. Doug, you stop me at the office?
No, I was in the first room and then I got some chairs.
example 1. Now example 1's pretty gosh darn easy, guys. I'm going to go ahead and we're going to label some stuff here. We have a point on the left. Label this point over here P. Label this point M. And label this point right here Q. And we'll call this point right down here T. All right, so go ahead and take a second and label those. Okay, guys, here's the deal. I'm going to put a mark right here like this. Anytime I put a tick mark in here like this, anytime I put a mark here and a mark here like that, that indicates to me that PM is equal to what here, guys? MQ. Okay? So let's go ahead and see if we can't find some segment lengths that they want us to use here. It says in the figure, PM is equal to what, guys? 1.8 millimeters. So from P to M right here, from P up to M, that is 1.8 millimeters. 1.8 right there. Okay. It says identify the segment bisector of PQ. Okay, so first of all, the segment bisector what's cutting PQ into two equal segments? Is it a ray? Is it a line? Is it a point? Is it a plane? Is it a line segment? What's coming off the middle of PQ, guys? It's an arrow. How would you describe that arrow in terms of a geometric term? Not quite a line, but a ray, right? Okay. How am I going to name that ray, guys? M what? Okay. Segment bisector is the ray, which we denote by an arrow up here. Start at M, continue through T. That's your segment bisector right there. So when I ask you, hey, what is the segment bisector to what's given up there? You can either say, hey, it's a point, or it's a ray, or it's a line, or it's a line segment, or it might be some kind of a plane. You need to identify what it is. Okay? Then the second part of this says, once you've identified that segment bisector of PQ, find what distance, guys? Find what distance? P to Q. So P to Q, that segment P to Q. All right, here we go. Well, guys, what do I know? I'm trying to find the distance from P all the way up to Q. How about thoughts on that? What are your thoughts on that? Give me a show of hands. Anybody have an idea on how to find PQ, knowing that M is the midpoint? To what? Okay, so you're saying if P to M is 1.8 and M is truly the midpoint, that makes M to Q what distance, guys? This is also 1.8 right in here, isn't it? So isn't PQ going to equal that distance of 1.8 plus 1.8? Therefore, the distance from P to Q, what's that add up to, kiddos? 1.8 plus 1.8, what's that add up to? Say it again, Chelsea. 3.6, and I can't remember what unit they were using on this. This would be 3.6 millimeters, right? I agree. So quickly, guys, if I say identify the segment bisector, can you like identify the ray off this? Like, yeah? Okay, and then if I ask you to find some unknown segment lengths, couldn't you do that? Give me some sort of sign that you might be alive right now, especially with 2 hours extra sleep.
Not really for me. I hope so.
Okay. Anybody need more time with example 1 here today? Okay, let's jump into example 2 then. Everybody down the first page here? Yes? Okay. So in example 2, kiddos, here's the deal. This is where things get pretty interesting. Now, what I would like you to do is this. I really like example 2. It says we're going to use some algebra with the segments. And I'm going to go ahead and label some stuff here again, guys. I'm going to call this A. I'm going to call this B right here. So you do the same thing. I'm going to put a midpoint M right about here. And I'm going to put some tick marks right here. So let's go ahead, and that's what you're going to want to add in there for your drawing. Looks like I've already done that. Okay. So guys, it says point M is the midpoint of segment AB. What do we need to try and find the length of? What do we need to try and find the length of? Okay. First things first. Listen to what I say here, guys. If M is the midpoint, do you agree that the distance from A to M is the same from the distance of M to B? Would you guys agree with that statement?
Yeah.
Okay. And they're equal because there's a tick mark here, right? Yeah. So I'm going to simply say, well, you know what? The distance from A to M has to equal the distance from M to B. You guys cool with that? So what it means is this. I have an expression up here for the length of A to M. What is that expression? 3x minus 4. So we're going to take that expression, 3x minus 4, and we're going to substitute it in for the length of segment AM. So in this here, we simply say, you know what? That expression, 3x minus 4, has to equal the expression that was given to MB. And what is the expression given to MB, kiddos? 2x plus what? 2x plus 1. So again, whole idea is this, that if M is the midpoint, this distance from A to M is the same as this distance from M to B. So I take each expression, and all you're really doing, guys, is taking the two expressions and setting what between the two expressions, guys? An equal sign. Okay? This is something we covered long ago, early in the first trimester. Equations with variables on both sides. I don't like having this positive 2x right here, so what do you want to do? You bet. Subtract 2x. Subtract 2x. All right, help me out, kids. On the left side, what's 3x minus 2x? 1x, right? And how about over on the right? Oh, back up. I messed up. 1x minus what? What did I forget? Minus 4. Boy, I'm a little rusty even. It's been a while since we've done that. Whew. Good thing I wasn't in the baseball game facing a full count with 2 outs in the bottom of the ninth and bases loaded. I'd have struck out. What are you going to have on the right side here, guys? 1. Okay, what's next? Add 4. So if I add 4 to both sides, what's that make your x value?
5.
All right, so all we've established is that x is equal to 5. Now, once I've established that x is equal to 5, I want you to jump up and find out, what does that question really want to know here? What is the question you want to know? What are they asking us to figure out, guys? Find the length from A to B. The only thing I've done is solve for x. So thoughts on how you might use that value of x to figure out what's wanting or what they're wanting to know, the length of AB. Anybody have thoughts on that? Say, Chelsea.
Put it in the equation.
Okay, put it in the equation. So anywhere where I have an x, I want to replace x with what value? 5. So right up here on this side, this will really become 3 times 5, which is what, guys?
15.
So this is really going to become 15 minus how much?
4.
And what's that make this down here, guys? 11. So the distance from here to here is 11. Now you'll know you've done stuff correctly again if I go ahead and plug 5 in over here on the right and get what value out again? Because M is what point on that segment? Okay, so let's check it out. What's 2 times 5 here, guys?
10.
Plus 1 more. What's that make this distance? Can I make that 11 as well? You guys agree?
Yep.
So what's the answer to the question here?
22.
22 units. Okay? So here's the whole deal. Once you solve for x, are you done? No! You're not done. Okay? You've got to substitute that back in to make sure that you answer that question that they're asking you to figure out. So make sure you substitute. I'm going to make a note down here. Once you solve for x, I'm going to write this down. Now substitute and solve. Now sub and solve. Sub and solve. Okay? If I had a sub right now, all my problems would be solved. Especially from Sub City, which I think is my favorite place for subs.
I've never gone there, so I don't
You've
know
got to
what's
go to
fun.
Sub City.
I'm trying to
Best.
convince my mom and dad to go there.
Number 3 with all the stuff on it, okay? What's the distance from A to B then, kiddos? What's the distance from A to B?
22.
Yep, it's 11 plus 11, which is what value?
22.
22 units. Very good. Very good, guys. Now again, midpoint. You just got to think, all right, divide stuff into 2 equal segments. Midpoint's right in the middle. All right? So guys, what I want to do then is this. I want to start looking at finding midpoints of points in a coordinate plane. And I'll show you how this works today. I'll really show you how this works. It's really pretty easy. Okay? Questions about that example to that point right there? Are we okay with it at this point?
Yep.
Okay, so let's take a look here at this next one and see what we can come up with. Now guys, here's the deal. At the very beginning of this class I said, where is the very middle of 4 and 10? Jen, are you going tonight?
No.
Okay, where's the very middle of 4 and 10? What did we say?
7.
7. It's like taking 4 plus 10, which is 14, and then cutting in. Cut that in half, right? Cut that in half. So midpoint formula is going to work like this. First of all, you need 2 points to use the midpoint formula. You need 2 points. Okay? You guys remember when we did the slope formula? Y2 minus Y1 over X2 minus X1 long ago? You guys remember doing something like that? Okay. Kind of the same setup here. You need 2 points. You need a first point, which is defined as X of 1, comma, Y of 1. And then a second point, X of 2, comma, Y of 2. So here's what I'm going to tell you right here. Formula for any midpoint. I'm going to call the midpoint M. The midpoint M is going to equal the following. It's going to equal the average of the x's as your first coordinate and the average of the y's as your second coordinate. So the formula that you really want to write down right here is the following. x1 plus x2 all over 2, comma, y1 plus y2 all over 2. Okay, the midpoint. And you know what I'm going to do right down here, guys? I'm going to go ahead and put a small xy down here like this. The midpoint in x comma y form. And this is just all notational stuff, so it's not real important, but I'll show you why I'm doing that here in a second. Do you guys have the formula here in blue? Might want to put a box about it or an exclamation point by it. Important. You're going to have to refer to this. Okay? So let's take a look at this. Here's what I want to do. While you're getting that formula down, I'm gonna load up a coordinate plane here. See that? I can do magic there. You're like, oh brother, stop, right?
What?
Never mind.
I don't even understand.
Okay, let's read through part A together. Question?
I just have a proposition.
Yes?
If I gave you punch, would you raise my grade 5%? Are you trying to brag a teacher?
What are the conditions of the punch? When you say gave, you might like, give it 2 years from now, give it now,
No, like,
a lifetime supply, maybe you get it 3 times a week.
Anytime you
I need a
want.
conditional.
Like,
Is this unlimited or is it a one-time
no,
deal?
It's a 2-time deal.
A 2-time deal.
2%.
Make it 3. I don't know.
Make it 10 and we'll talk.
Make it 15.
In negotiating, you always start way high,
Yeah,
and then
that's
they'll
what I
take you down, so you can meet in the middle where you
I'll simmer
would
down.
ultimately probably wanted to be, but you might be a little better off.
I don't know. I think I'll simmer down at 3.
3. Boy, I tell you what, I'm holding pretty firm on 10 right now. gotta tell you.
Oh my God.
Take that back to your people, talk to them, see what you can come up with. I'll run it by them, I'll see what my people say, but
Run it by my associate.
I can pretty much tell you what my people are gonna say. They're gonna be like, you know what, do. Okay, so you think about it, take it back to your people,
All right.
do some more thinking, okay? All right, let's talk about this. I want to get through A and B, and we'll call it good here for the day today, all right? It says the endpoints of a segment AB are the points -8, 7, and 5, 1. I'm going to go ahead and graph those. You don't need to graph these. Remember those 2 points. You tell me what they are. Guys, on this graph right here, what 2 points am I graphing again? -8, -8, 7, so left 8 and up 7, which is right here. What point do they call that? A. And what's the other point?
5, 1.
Right 5 up 1. B. So there's a line segment right here. There's a line segment right in here. You don't have to draw this, just pay attention. Okay, we're trying to find the midpoint, or the coordinate of the midpoint for that. Gosh, guys, the midpoint for me, it kind of looks like it might be right about, maybe kind of about in here somewhere. Do you guys agree? Kind of see where I'm pointing?
Yep.
Okay, I think it's pretty close to that. We're going to see what it actually is here by formula. And then we'll come back and plot it and see if it looks like it hits the middle of that line. Is that fair? So keep in mind, they gave you A and B, which are 2 endpoints here, didn't they? Gave you A and B, which are 2 endpoints. Okay, no problem. Let's go back to the formula. Okay? I'm going to call A point 1, and B is always going to be point 2. My point 1, my point 2. Okay, let's find this midpoint. My midpoint becomes the following. Midpoint, in terms of a coordinate x, y, is the following. First point, what's the x value?
8,
-8. So you're going to go -8. That's the x1. Plus x2. So second point, what's the x value of the second point? Plus 5 divided by what, according to the formula? 2. Comma. All right, what's y1, kiddos? 7. What's y2?
1.
All over. All right, so we've got some thinking to do. What is -8 plus 5? What's -8 plus 5 for this first coordinate here? -3 divided by 2 is? -1.5. Okay, and then how about 7 plus 1 for the second coordinate? 8 divided by 2. So we think the midpoint is left 1.5, -1.5, and then up how much? Let's see if you can help me remember that coordinate. Left 1.5 and up how much? 4. Okay, help me here. Let's go back right here. I'm going to go left 1.5 and then up 4. Holy cow, that point's on the line, so that's good, isn't it, guys? Left 1.5 and up 4. Doesn't that hit right there? What are you going to call that point if it's the midpoint then? What letter do we denote for midpoint? M. Okay. So the midpoint of that segment, by golly, it works. Looks like -1.5, comma, 4. All right? -1.5, comma, 4. Whew. Yeah, I would. I would write down M and then equals -1.5, comma, 4. And I'd put parentheses around it, okay? Okay, so, you know what? I think we get out at what time here today? 56. Boy, I don't know. I don't think I've got enough time to get to that next example B. So I'm going to stop right here, guys, and we'll pick up the rest of this tomorrow. So